In this section, we are going to look at arithmetic and geometric sequences and series. So a sequence is a list of numbers formed using some pattern. So for example, 3, 6, 9, 12, or 1, 2, 4, 8, 16. The sequence is the list of numbers. A series is a sum of a sequence. So for example, if we took the two sequences that are given here and we added all of those numbers together, that would be the series. So 3 plus 6 plus 9 plus 12 plus so on would be the series that goes with this sequence. So we're first going to start by talking about arithmetic sequences. An arithmetic sequence is a sequence formed by adding a constant to each successive term. So you're adding a number each time. Like we see here, 3, 6, 9, 12. You're adding 3 each time. That number that you're adding each time is called the common difference. The common difference, you'll see as D here, is the constant number that is being added. So, for example, if we were supposed to find the common difference and give the next 3 terms for these, we're looking for the pattern that is happening here. So let's grab the calculator real quick for this. So we've got 2.5, 0.8, negative 0.9, negative 2.6. So we can see that this is decreasing. If you want to find the common difference, you can always just take a term. Oh, let's go back here. So 0.8 and subtract the term that's before it. So minus 2.5. And we see we get negative 1.7. If we had chosen to do negative 0.9 and we subtracted 0.8, we'd also get negative 1.5. Negative 2.6 minus negative 0.9 would also give us negative 1.7. So our common difference here, which I'm going to call D, is negative 1.7. If we needed to find the next few terms, we would just take negative 2.6. We would subtract 1.7. That would give us negative 4.3. You'll notice how I've typed this in here. Now I can just hit enter. We get negative 6 and negative 7.7. For part B here, I've got x, x minus 4, x minus 8, x minus 12. So each time here, I'm going from x to x minus 4, I subtracted 4. And then I subtracted 4 more, and that gave me x minus 8. I subtracted 4 more, and that gave me x minus 12. So my common difference here is negative 4. The next 3 terms would be x minus 16, x minus 20, and x minus 24. That same trick that we used on part A can also be used on part B. We could take x minus 4 and subtract the term before it, which is x, and that would give us negative 4. So we can use that same rule even on one that doesn't have numbers. A recursive formula is a formula that defines each term by one or more of the preceding terms. So, for example, if we have an A with a little subscript here that says 1, that is our first term in the sequence. A sub 2 is our second term in the sequence. The nth term would be A sub n. The term that comes before the nth term would be A sub n minus 1. So if we look at this pattern here and we're asked to write a recursive formula for this pattern, we see we've got 0, 1, 2, 3 up here. Everything's increasing by 1. And we start at negative 3. Then we've got 7, 17. So it looks like what's happening here is we're adding 10 each time. You may remember doing this sum from Math 1. So what you'll have here is your A sub n term is going to equal A sub n minus 1 plus 10. We'll also on this give a start value sometimes, so you might be given a value to start from, so like A sub 0 would equal negative 3. That's not necessarily always included. But right here, if you think back to Math 1, what we did sometimes for this is we said next equals now plus 10. So we take what we have now, we add 10 to get the next number. Next is your a sub n. Now is your a sub n minus 1. The n minus 1 would be the number that comes before the a sub n here. If we look at example 3, it says to write a recursive formula for 2, 3/2, 1, 1/2. So we can see here that what's happening is we're subtracting 1/2 each time. So we're going to have a formula where a sub n equals a sub n minus 1 minus 1/2. Sometimes we're given these really complicated recursive formulas. So we're given in this case a sub n equals a sub n minus 1 plus 3n minus 1. And they tell us that the first term is 2. Find the next 4 terms in the sequence. So they're telling us that the first term, which I'm going to call a sub 1, is 2. And we have to find the next terms. So what we would do here, if we're looking for, we already have a sub 1, we need a sub 2, a sub 3, a sub 4, and a sub 5. So we would have a sub 2 is what we're looking for. That means that n equals 2. So we would have a sub 2 minus 1 plus 3 times 2 minus 1. So a sub 2 would equal, here this would be a sub 1 plus 6 minus 1. And a sub 1 they gave to us, it was 2. So I'd have a sub 2 equals 2 plus 6 minus 1. And that, whenever I evaluate that, will give me 7. So a sub 2 would be 7 there. Next, I would find a sub 3. So when I find a sub 3, I'm replacing all of my n's with 3. So I've got a sub 3 minus 1 plus 3 times 3 minus 1. So in this case, a sub 3 minus 1 is a sub 2. And that'll be plus 9 minus 1. And a sub 2 we just found on the last problem, so that'd be 7 plus 9 minus 1. So that gives us 16 minus 1, and we get 15 for a sub 3. And we would just continue this pattern. So for the next one, a sub 4 is a sub 4 minus 1 plus 3 times 4 minus 1. That gives us a sub 3 plus 12 minus 1. A sub 3, we just found it. It was 15 plus 12 minus 1. So that's 27 minus 1 will give us 26. So a sub 4 is 26. And then finally, to find the fourth term there, so a sub 5 would be a sub 5 minus 1 plus 3 times 5 minus 1. So this is a sub 4 plus 15 minus 1. That a sub 4 we just found is 26 plus 15 minus 1. So in this case, we will get 40. So a sub 5 is 40. And you, of course, could continue on that, finding as many terms as you needed to find. Okay. When it comes to arithmetic sequences, we have a formula that we can use to help us find different parts of a sequence. So whenever we're looking for different terms in an arithmetic sequence, we can use this formula here. A sub n equals a sub 1 plus n minus 1. In this formula, a sub n is your nth term, a sub 1 is your first term, and d is the common difference in the formula. The reason that we want to do this is because if we look like at example 5, we're asked to find the 43rd term in the sequence. And we see -3, -1, 1. So we can tell really easily here that this is just subtracting, I'm sorry, not subtracting. This is just adding 2 over and over and over again. And it's a pretty simple problem. Well, we could, in our calculator, we could start with -3. And we could add 2. So that was our first term, our second term. And then we could do 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, all the way up until we get to the 43rd term. The problem with that is whenever you're doing that repetitively, it's really easy to miss a term, to count wrong, and to be off just by a little bit. So this formula is going to be a little bit quicker, and it kind of ensures that we make fewer mistakes. So this number that we're adding each time, that is our common difference. That is our D here. We are looking for A sub 43, the 43rd term here. So that means this would equal A sub 1, which is our first term, which is -3 here, plus 43 minus 1 times our common difference, which is 2. So that N here is our 43. We replace that both here, and then A sub 1 is -3. So A sub 43, we don't do anything with that. That's what we're looking for. We're going to find here -3 plus 43 minus 1, which I know is 42. I could type that in instead, times 2 will give us 81. So we get 81 for that 43rd term. So the formula here will sort of help us make a little bit of a shortcut there. Let's look at example 3. Example 6. For example 6, we see that the sequence is given to us. It gives us the recursive formula here for the sequence. A sub n equals A sub n minus 1 minus 2/3. And they ask us if A sub 19 equals 42, we're supposed to find A sub 1. So here we're working from this formula, A sub n equals A sub 1 plus n minus 1 times d. Well, in this case we're not given A sub 1, that's what we're looking for. We want to replace everything else except for our A sub 1. Our A sub n here is going to be our 19th term. So that tells me that n equals 19 and A sub 19 equals 42. So I would plug the 42 in here where the A sub n is. I do not know A sub 1. I'm going to leave it here. And my n will be 19. So I have 19 minus 1. Now the d is not explicitly given to me, but I'm going to find the common difference here because they gave me the recursive formula for the sequence. And that recursive formula tells me that I take A sub n minus 1 and I subtract 2/3 each time. So that means I'm subtracting 2/3 to get to the next number. That is my common difference, -2/3. So this, I'm going to have to do a little bit more work to solve. So I have 42 equals A sub 1 plus 18 times -2/3. And 18 times -2/3 we could do pretty easily, or we can just type into our calculator -2/3, and we will get -12. So we've got 42 equals A sub 1 minus 12. We'll add that 12 over to the other side, and we'll get 54 is our A sub 1. So we see 54 is a number that we would start with. If you want to check this, you can by typing in 54 and subtracting 2/3. So 54 is your first term. Here's your second, your third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, and 19th term. And you see that you do get that 42 is your 19th term, so that can verify that you are correct. That first term is 50.